first of all, notation. So in mechanics, they use these letters, nothing else. S is used for displacement. Displacement is like distance with a direction. U is the initial velocity. V is the final velocity. A is acceleration. And T is the time. So SUVAT for short, SUVAT. Okay, so you can use that notation to illustrate the velocity time graph. So yesterday I showed you the velocity time graph, something like time against velocity. So if you've got some kind of velocity time graph, some object moving at a constant speed, something like that, straight line. Okay, so that will be the time taken to complete the motion. That's the origin. This is the time taken to complete the motion. So this point here would correspond to the starting velocity, the initial velocity. So that number would correspond to the u value. Okay, this point here, that would correspond to the final velocity, v. Like that. Okay, so also yesterday I mentioned that the acceleration is the gradient, that kind of stuff. Okay, so think about it. Okay, the acceleration of this, so if we worked out the gradient, we do the change in y, which is v take away u. So that's going to be that distance. V take away u. Divide by the horizontal, which is just t. But remember, in a velocity time graph, the gradient is the acceleration. In a velocity time graph, the acceleration is the gradient. So that's how you work out acceleration. Final velocity take away initial velocity divided by time. But if you rearrange it, you get v equals u plus at. So that's one of the formulas which is given to you in the formula book. So in the mechanics section of the formula book, you're given 5 formulas. This is the first one. V equals u plus at. So that's the first Suvad equation. The second one, the other thing you need to remember from yesterday, the area underneath the velocity time graph is the distance traveled. So from yesterday, you know that the distance traveled is equal to the area underneath this graph. Okay. If you work out the area of this graph, it's like a trapezium shape. So you've got like one side is u, this side is v. So work out the area of a trapezium. So u plus v are the parallel sides. Then you divide by 2. Then you times by the distance between them, which is t. So that's the distance underneath that graph, and the correct notation S. So that's the second Suvad equation. S equals final velocity plus initial velocity divided by 2 multiplied by the time taken. Examples. Okay, this one. So you've got a cyclist traveling along a straight road. She accelerates at a constant rate from a velocity of 4. So from a velocity of 4, that sounds like the initial velocity, but that sounds like u equals 4, the initial starting velocity, to a velocity of 7.5, that's the final velocity. Time taken, t is 40. Find the distance she travels in these 40 seconds. So for part A, you want to find the distance traveled. So you just use the formula u plus v over 2 times t. So you would do 4 plus 7.5 divided by 2 multiplied by 40. That will give you the distance traveled. So the units in this question would be meters. Okay, find the acceleration. So you want to find A. If you just use the formula directly, V equals U plus AT. Plug in the numbers. 7.5 equals 4 plus A is unknown, T is 40. Okay, so you just do the calculation. So A is going to be equal to 7.5, take away 4, divide by 40. And that will give you the acceleration. If you do that, you get, that's going to be meters per second squared. Any questions on those two? Example 5. A bit longer. Okay, so the first part, a particle moves in a straight line from point A to point B with constant deceleration 1.5 meters per second squared. So the deceleration means it's slowing down, the velocity is slowing down, so A is minus 1.5. So whenever you see deceleration or retardation, we're talking about a negative acceleration, negative 1.5. It's traveling from point A to B. That means the velocity at A is 8. That's the initial, that's the starting velocity. And the velocity at the particle of B, so it's going from A to B, so that's the final velocity, B equals 2. And the question says, find the time taken. So you don't know what T is. So you could just use that equation again. So you can just use straight away, you can say V equals U plus AT. So 2 equals 8, okay, minus 1.5 times T. Okay, then you just solve it. 6 divided by 1.5 is 4 seconds. Part B, also straightforward. It wants the distance from A to B. So it wants the formula for S. So you just plug in the numbers for S U plus V over 2 times T. So you know it's 8 plus 2 divided by 2 times by the time, which is 4. So that is equal to 20 meters. So the first part is straightforward, just like the first example. Okay, situation changes now. So remember, it's traveling from A to B. Now the particle continues to move along the straight line with a constant deceleration of 1.5. So the deceleration is still the same. So it's going to the point C now. Okay, so it's gone to the point C. So the deceleration throughout is still going to be the same. That's what it says. Okay, so there's no change in the deceleration. The particle is at the point C 6 seconds after passing through the point A. So A to C has taken 6 seconds. Okay, so A to C has taken 6 seconds. Okay, find the velocity of the particle at C. So you want to know what V is. So we know what A is. Okay, we also know the velocity at A. The velocity at A, remember, is 8. So we know at the beginning is 8 meters per second. Okay, we can use the Suvad equation to sort it out. So then we know that U equals 8, A equals minus 1.5, and we know it takes 6 seconds to go from A to C. So we can find out what the final velocity is at C. So you just plug in the numbers. V equals U plus AT. So you would do 8 plus minus 1.5 multiplied by 6. Okay, so that will give you 8 take away 9 is minus 1. So the velocity at c is minus 1 meters per second. So what that tells you is that the direction of motion has changed. The particles are moving from A to C, so we've taken this direction as being positive. That's the direction of motion. But because the velocity at c is minus 1 meters per second by this formula, that means the particle at c has actually switched direction. So the object at c is now moving in the opposite direction. So in the book it says the velocity 1 meter per second in the direction BA. So if you want to be precise, the new direction is BA. So you can say direction switched or direction reversed. Direction reversed to BA, the BA direction, or within the or in CB or CA direction. It's up to you. Is that okay? Yeah, that's part C. So the velocity at C is negative 1 meters per second. Part D, you want to find the distance from A to C. You want to use that formula again, SU plus V over T. So for part D, the distance from A to C, then just plug in the numbers. U plus V over 2 times T. So in this case, at A, it's 8 meters per second. Okay, at C, it's negative 1. So you need to use negative 1. Divide by 2 times by 6 from A to C, 6 seconds. Okay, then you just work it out. 21 meters. Last example. A car moves from traffic lights on a straight load, constant acceleration. The car starts from rest. That means it's not moving. So it sounds like U is 0. 30 seconds later, T is 30, passes a speed trap where it is registered as traveling. So that's the velocity after 30 seconds. Okay. So 45 kilometers per hour, you need to work in the right units. Remember, this is all meters per second. So if you've got 45 kilometers per hour, you need to convert it into meters per second. So you do 45,000 meters, and you divide by 3,600. Yeah. 3,600 seconds in 1 hour. That'll give you the velocity in meters per second. That'll give you 12.5 meters per second. Okay. So that's the final velocity as it passes the speed trap. So you've got U, you've got V, you've got T. So you can work out the acceleration. So it's just V equals U plus AT. So you can plug in the numbers. 12.5 equals 0. A multiplied by 30 seconds. So A is 12.5 divided by 30. So the acceleration will be 5/12 meters per second squared. Okay, and the distance is just the S formula. So you do plug in the numbers for this one. So initially it's 0 from rest. V is 12.5 meters per second over 2 times by 30 seconds. Okay, do that calculation. That'll give you the distance traveled up to the traffic lights.